Good afternoon. I am Jamie Arenas. I am a student at Industrial Engineering at UNAT. Today, with my classmates Cindy Bello, we'll talk about nanosensors for prediction and maintenance. Go. Developed of the report. Nanosensors for predicting maintenance. These are small, wireless nanoscale sensors that adhere to the suburban of industrial maturity. This sensor monitors variables in real time, such as vibration, temperature, and material stress. They use artificial intelligence to analyze the data and predict failures on maintenance needs before they occurs. Two, intellectual properties analysis. Types of projects applied. The invention of the nanosensors and the prediction algorithm can be projected by patents. The data analysis software or the platform's brand will be protected by copyrights and trademarks. 212. Strategy of technology protection and possible obstacles or startups and multiple intellectual property IP access to project. A combined strategy is essential to convert and innovate aspects of technology. Patents. This is main protection. Patents will be required for the nonsense technology and including the unique the change materials using and manufacturing process. 13 seconds. The explicit and highly complex code as will be as the proprietary data models using by algorithm can be protected and traded secrets. Copyright the software interface, user manuals and an original protocol documents are automatically protected by copyright. Registrations is not required, but it can provide a stronger legal legitimacy in the event of a dispute. Trademark. The product name AG Nanosensing Pro and the company logo should be registered and standard markets. This is projecting the brand identity and prevents competitors for confusion customers with similar names. 3. Technology feasibility assessments. 313 feasibility. The solution addresses a critical need in the industry's reducing implant downtime and maintenance costs. 312 competing advantages. 1. A reduction of operation constants, proactive versus reactive maintenance. 2. Longer equipment lifespan. Constant monitoring by monitoring key variables, shoots and temperature, vibrating and material stress in real time. Nanosensors can detect irregularities of wear that are not visible to the naked eye, helping prevent serious damage and extending equipment lifespan. Prevention of unplanned downtime avoids rapid equipment deterioration and unstable machine stupid, improving overall and safe ability. 313 inductions that could adapt it. Uh, this and third, the technology could be used in automobiles manufacturing. It could also be presented on more modern platforms. Enabling its application in aviation, energy, and civil infrastructure. Fourth, invents right analysis. Fourth one, financial technology and market rates. 411 technology or technological rights. There is rights that the technology may not work as expected. For example, sensor could be damaged under harsh industrial conditions, or AI prediction may not be suffered accordingly. 412 Market rates. The market may not adopt the technology as working as expected. Industrial are essential to change. 413 Final rates. Developing and commercializing its technology requiring significant capital. There is a risk that the startup could often out of funding, benefit, reaching profitability. Fourth, two, starting to minimize risks. Um, Technology, this can be method to write recurrent debts, having development time. For to marking. The rates can be minimized by targeting early adopters of often pilot programs. 423 Financial mitigation including is seeking funding from multiple sources, clarifying minimizing expenses, and having unclear final forecast. Um, Next, so thank you very much. Bye bye.
Is Cindy Bello, a student of Program Engineering Industry. 5.1 Development of Making Plan and Technology Transfer. Marking Plan. Market segmentation. Identify industries with high demand for predict maintenance. Example, petrochemical, have manufacturing, mining, energy. Focus on companies already adopting digitalization industry 4.0. Value proposition. Reduction of maintenance costs and unplanned downtime, increase safe and productivity, innovate technology, nanosensors, AI. Us a competitive advantage, merge and try strategies. Offer pilot programs free of charge or at low cost to demonstrate results. Create success stories with metrics on savings and efficiency. Participate in technological and industrial fairs. Promotion channels. Digital marketing, linked, especially websites, webinars. Partnerships with industrial associations. Publication in technical and scientific journals. Pricing model. Hardware sales, nanosensors. Monthly annual subscription for the IA data analysis platform. Maintenance and technical support service. Technology transfer plan. Intellectual property protection, patent registration for nanosensor design and predict algorithms, strategic alliance, collaboration with universities, research centers, and technology clusters, agreements with industrial companies for real-world testing, production scalability, functional prototype design, pilot testing, mass production. Agreements with manufacturers, especially in nano microelectronic sensors. Training and support. Training programs for company technicals. Operation manuals and specialist after sales support. Feedback and continuous improvement. Integrate customer experience into the development of new versions. Open innovation. Adapt the solution to different industrial sectors, strategic for the management of parents, license, or commercial agreements that apply. License views direct selling. You can choose to license the technology to a large industrial partner that already has a presence in the target sectors. Alternative, you could sell the technology direct as a service, SIIS, or as a product. The modular design makes a leasing model very attractive. Pricing strategy. You could offer a tiered pricing model based on the number of sensors or the volume of data processed. This allows it to cater to both small and large customers. Step 6. Strategy for protection and management of intangible assets. 6.1 Marketing and Technology Transfer Plan. As an industrial engineering student, I consider that to minimize the previously identified risks, it is necessary to have a structured marketing and technology transfer plan. Regarding the marketing plan, the strategy focus on three pillars. Marketing positioning. Start with pilot programs in companies interested in technological innovation, mainly those already applying digitalization process under the Industry 4.0 approach. Clear value proposition demonstrate through real results the ability of nanosensors to reduce unplanned downtime, increase production efficiency, and generate maintenance cost savings. Dissemination and promotion. Leverage digital media alliance with industrial associations and participation in technological fairs to promote the solution. In the technology transfer plan, the strategy is aimed at establishing alliance with universities, research centers, and companies to carry out pilot tests that validate the technology in real scenarios. Once its effectiveness is proven, the goal is to scale up production through agreements with specialist manufacturers and support implementation with training programs for company personnel. 6.2 Strategies for the management of patents, license, and commercial agreements. To protect the project's intangible assets, it is essential to establish an intellectual property strategy that warrants exclusive and the proper exploitation of innovation. Patent management. Regis patents relate to the design of nanosensors and artificial intelligence algorithms. This ensures the legal protection of the technology and prevents unauthorized use by third parties. Licenses. Once intellectual property is consolidated, was license can be granted to companies that want to implement the solution, thus generating an additional source of revenue. Commercial agreements. It is advisable to sign agreements with industrial companies for the distribution and application of the technology. Additional collaboration agreements with strategic suppliers can be developed to ensure production scalability. Conclusion of the job. The development of Nanosensors for predicts maintains demonstrates the importance of integrating advanced technology such as artificial intelligence and nanotechnology to optimize industrial process. This innovation can significantly reduce downtime and maintenance costs, which is essential for improving productive and competitiveness. Protect intellectual property through patents, copyrights, trademarks, and trade secrets is a key strike to ensure the sustainability and value of the startup. At the same time, this measure build trust among potential investors and partners, which facilitates the transfer and adoption of the technology in different industries. Although financial, technical, and market risks are present, they can be minimized with strong strategies such as rigorous testing, pilot programs, and diversified funding. As an industrial engineering student, I conclude that the success of this project depends not only on the innovation itself, but also on effective management of recurse, risks, and technology transfer. Very thanks for your attention. Good day.